Good evening. We are going to discuss CSC 120 Quiz 4. So here are the assignment questions. For the given logic circuit diagram, write the unsimplified Boolean equation that make the truth table. So we are moving towards the solution and we are going to translating between algebraic expressions, truth tables and the logic circuits of the given diagram. So first of all, we are going to identify the type of the gates in the logic circuits, and after that we will have the instances of AND, OR and NOT gates. So here are some instances. AND gate will be A dot B, OR gate will be A plus B and NOT gate will be A naught. So now we are going to combine the outputs of these gates to form the complex Boolean expressions. So first of all, we will assume that inputs will be A, B and C, and after that we will use the AND gate for A and B followed by the OR gate that takes the output of the AND gate and C. After solving all of this, the Boolean expressions would be something like Q is equal to into A dot B bracket close plus C. So here we will get 2:3, which will be total of the 8 combinations, and the values will be something given in the tables. So here you can see that in a row A, B and C are given below. And now we are going to see A dot B. So as you can see that 0 multiplied by 0 will be a 0. So we will assume this as the multiplication process. So here if the negative will be multiplied by a negative, so it will be a negative value. And if the negative value will be multiplied by a positive value, it will be still a negative value. And if there will be two positive values, then it will make a positive value. After that, we are going to see the next step of this, which will be Q is equal to into A dot B bracket close plus C. So here we are combining the two processes A dot B and then a plus C. So here you can see that the value of A dot B and here is a separate value of C. So we are going to use the addition process, like you can say that 0 plus 0 will be a 0, 1 plus 0 will be a 1 and 0 plus 0 will be a 0. Same will be for all the values, like 1 and 1 will be a 1 and 0 and 1 will be a 1. But a 0 and 0 will make a 0. After that, the table will be completed. And now we are going towards the P2 section where we are going to construct the circuit diagram. So for a logic circuit diagram, we are going to follow the rules. And the rules are NOT gates, create NOT gates for the Z and Y, create an OR gate that takes Y and Z naught as the input. And for the AND gates, first the AND gates take X and the output from the OR gate. Second AND gates takes X and Y naught. So after completing all of these, the output we will get as the logic diagram will be followed as this one. So here you can see that X and Y are attached to the AND gate and Z is followed by a NOT gate, and all of these are connected to our gate. Then our final value Q is attached to it. After that we are moving towards our second portion. Here is the target forces section. So for this given table we are going to find out CSOP equation, simplest possible SOP equation and CPOS equation. So first of all we are moving towards CSOP equation. So in this equation, first of all, we will look for all rows where Q is equal to 1Q. Now here you can see that the canonical SOP is the sum of the product terms for these rows. In each product term, write the variable if it's 1 and write the negation if it's 0. So in our case, Q is equal to 1 and for all the rows, it will be something like this. And the result gained by all of this is given as this one. So here is the canonical SOP. After that, we are moving toward the simplified SOP. So we are going to apply the Boolean algebra rules to simplify the expressions. After solving this, it will give yz0 plus yz. After that, we are going to find out the CPOS. So here we'll be looking at Q is equal to 0 for all the rows. The canonical POS is the product of some terms of these rows. So we will be writing a variable if it's 0 and a negation if it's 1. So for the given truth table, Q is equal to 0 in the following rows. And the result of this will be compiled as this one. After that, we are moving towards the definition of canonical. So canonical refers to the standard or complete form. So basically in Boolean algebra, the canonical form is the full and explicit variant of the equation where each terms include all variables, either in normal or negated form. So for this, we are going to find out a good example which will explain it exactly what is it. So if there is a switch A and switch B, which are like magical switches, so the light only turn on when switch A is up, on, and switch B is down, off. So we write rules to make sure every switch is mentioned, and that's called the canonical form. It means we write a complete magical spell to explain when the light will be turning on. So it was all from my side. I hope you will like it. Thank you very much.